Hello and welcome. In this presentation, we will be discussing the problem titled Max sum of a pair with equal sum of digits. We will walk through the solution approach and its implementation in C++. The problem gives us a zero-indexed array of positive integers. Our task is to find two indices I and j such that the sum of digits of the elements at these indices are equal. We need to return the maximum value of nums I plus nums j. Let's look at a couple of examples. In the first example, the input is nums, which contains the elements 18, 43, 36, 13, 7, and the output is 54. In the second example, the input is nums with the elements 10, 12, 19, 14, and the output is -1 because there are no two numbers with equal sum of digits. Now let's discuss the approach to solve the problem. First, we compute the sum of digits for each number in the array. Next, we use a hash map to store the largest number corresponding to each digit. As we iterate through the array, if the digit sum already exists in the map, we check if the sum of the current number and the stored number is greater than the current maximum pair. Finally, we return the maximum pair sum or -1 if no valid pair is found. Here's the first part of the C++ implementation. We have a utility function, sum of digits, that takes a number and returns the sum of its digits. This function iterates through each digit of the number and adds them up. Moving on to the main logic, in the main sum function, we use an unordered map to store the maximum value corresponding to each digit sum. For each number in the array, we calculate the sum of digits and check if it's already in the map. If it is, we update the maximum possible sum. Finally, we return the maximum pair sum or -1 if no valid pair is found. Let's now analyze the time complexity of our solution. The sum of digits calculation for each number takes big O of log m, where m is the maximum number in the array. Iterating through the array of n elements takes big O of n. Operations with the hash map, such as insertions and lookups, take big O of 1 on average, so the overall time complexity is big O of n log m. Let's walk through an example. Here we have an array nums with elements 18, 43, 36, 13, 7. The sum of digits for 18 is 9. The sum of digits for 43 is 7. The sum of digits for 36 is 9. The sum of digits for 13 is 4. The sum of digits for 7 is 7. We find two valid pairs 1836 with a sum of 54 and 43 7 with a sum of 50. The maximum sum is 54. In terms of edge cases, we have considered several scenarios. If there's only one element in the array, we return -1. The algorithm can handle large numbers up to 10 to the power 9. There may be multiple numbers with the same digit sum. If no valid pair is found, we return -1. To summarize, the approach uses a hash map for efficient lookups and updates. The time complexity is optimal for large constraints. This approach is especially useful in problems involving digit-based classifications. Thank you for your attention, and I would be happy to take any questions now.